Okay, Algebra 2, here we are. We've got the second part of 6.6. So if you have exponential equations, we talked about a couple other ways to solve those, but now we're going to solve logarithmic equations. Here is the property. If b, x, and y are all positive real numbers, very important, positive real numbers, b can't be 1, then the log base b of x equals the log base b of y, if and only if x is equal to y. So we have an example here. If log base 2 of x equals log base 2 of 7, then x equals 7. And if x equals 7, then the log base 2 of x is equal to log base 2 of 7. So this is what we're going to work on, this assumption. We're going to do a couple more examples, and I'll show you at least 2 more ways to solve going this way. Get your notes ready. Okay, so here's our first example. I have a logarithmic equation, and I want to solve it for x. So the first thing we have to realize is that this right here, this argument, as they're called, has to be positive. Okay, that is one thing that we need to always check. So you will need to check at the end once you get your x to make sure that's a number that works. And basically what you're going to do is you're going to change this logarithmic form into exponential form. So remember, here's your base, here's your exponent, and this is the answer. This is what it's equal to. So what you can do is rewrite it like this. The base to the exponent is equal to 10x minus 9. And look, that's a problem that you are easily able to solve. You know 3 to the 4th is 3 times 3 times 3 times 3. You just use your algebraic skills, add 9 to both sides, divide both sides by 10, and x is equal to 9. Of course, if you're going to write it in set notation, the solution is 9, and it's okay, it's positive, that's all good. So we're going to do another example. So my second example is log base 2 of x minus 6 is equal to 5. Again, we're going to change this into exponential form, which means 2 is your base, 5 is your exponent. So 2 to the 5th power is equal to the argument of x minus 6. 2 to the 5th is 32. You're going to add 6 to both sides to isolate x. Voila! X equals 38. Again, a positive number, all good, and so our solution set is the number 38. Okay, perfect. Ready to go on. Next. The next type of logarithmic problem we have, we're going to affectionately call matchy-matchy. So if you have a logarithmic equation with the same base, they're both base 2, then really all we need to do is match up the arguments, okay, because of that property that we went over on the first slide. And so all you're going to be doing is you're going to set 5x plus 2 equal to x plus 10, and you'll do your algebra to isolate x. We're going to subtract x from both sides to get 4x here. You're going to subtract 2 from both sides to get 8 here. Now that I have 4x equals 8, I'm going to divide both sides by 4, and I get 8 divided by 4 being 2. We're all positive, it's good, there's our solution set, and again, that's called matchy-matchy. Okay, scholars, we have arrived at our third method. These are the ones that are a little more involved, because now those rules that we learned in 6.5, the quotient rule, the product rule, and the power rule are come into play. Now what we're going to do is we're going to combine arguments using those rules. So again, we do have to be careful that our arguments remain positive, okay? But one thing you should recognize from 6.5 is this is a plus, which we're talking about the product rule. If they're both the same base, which they are, log 6, then we can rewrite this like this. Log base 6 of 6x times x minus 1 equals 2. And you may recognize at this point, basically what we're going to do is we're going to put this base to this exponent, and it's going to equal this argument. So let's rewrite that. It'll be 6 to the 2 power equals 6x times x minus 1. Now I know some of you already have spotted this, but what is it that we have here? 6x times x is going to give you a quadratic. So I have 36 equals 6x squared minus 6x. And you think to yourself, what am I going to do next? Okay, so anytime you see a quadratic, the first thing you want to do is get everything on one side. Okay, the only way we're going to be able to solve this is to make it equal to 0. So I'm going to take that 36 over on the other side, and I'm going to try to solve the quadratic. And so the next thing you should recognize, of course, is that they are all factors of 6. So I'm going to move up here, not factors, multiples of 6. So I'm going to factor out of 6, which makes the numbers a lot easier. If you divide both sides by 6, you get x squared minus x minus 6. And then we can actually just factor that. We put our parentheses. We know that x squared is going to give us x times x. And then the two numbers that go here, remember, they have to multiply to give you negative 6. But when you add them together, you're going to get a negative 1. So those numbers are going to be minus 3 and plus 2. And then we're going to use the zero product property to set this one equal to 0 and this one equal to 0. So this one gives us x equals 3, all well and good, but this one gives us negative 2. So we go back to the beginning. This is not going to be a solution, which means here is our only solution. So it has to be x equals 3, and that's how you use the product rules. We're going to do another example, so get ready. So for the fourth example here, we have another log equation, same basis, they both have 4. So this plus here is going to allow me to apply the product rule again. Very similar. If there's a minus, I would use the quotient rule. And let's go to solve the equation. So then these two arguments here, we're going to be able to put them together. So it's now log base 4 of x plus 12 times x equals 3. At this point, we can put it into exponential form, which means here's our base, and here's our exponent. So it's 4 to the third equals, I'll just go ahead and multiply this out, x squared plus 12x. So now that you see that x squared, you know your strategy is going to be to set it equal to 0. This is 64, so if I take away 64 from both sides, then I get 0 equals x squared plus 12x minus 64, and we're back to our factoring x times x. We know whatever numbers we figure out, it's got to multiply to give you negative 64, but add together to give you 12. Give you a second to try to figure that out. Remember, you do your little pairs, factor pairs. Can't figure it out. 3 doesn't go in. How about 4? 4 times, oh, yeah, 4 times 16. And I know this is also 8 times 8. So I know it's going to be 4 times 16. And I figure the positive has to be the 16 because I want a positive 12 in the middle. So it's going to be plus 16 and minus 4, which means this, using the zero product property, would be negative 16, and this would be positive 4. And so clearly that's not going to work. It has to be positive. So x equals 4 will be our example. Hopefully this is enough for you to see how to solve these equations we have tasked you with. So we're going to give you a whole extra day to practice with them. You've got some examples. I may actually do a problem or two tomorrow as well, so check back. But in the meantime, this is plenty for you to look through, digest, really understand how those rules work, and post any questions or send me an email. Of course, Mr. Adinich and I are working together. So good luck with this. More examples in your book. All right, bye.